Hello everyone, my name is Vivek Srivastava and I am from ABES Engineering College, Ghaziabad. In today's lecture of DBMS, I will discuss about reduction of an ER model to relational tables. So in this lecture, I will cover the topic how to convert ER model to relational table in populated relational database. And I will show some examples also. First of all, we should understand what is relation. Relation is a set of tuples records where each element Ti, an element of tuple, belongs to the domain Di. The domain is a set of values that an attribute can hold. Example, the domain for attribute roll number of an entity type student is the set of all roll numbers. These relations are also called tables, and each relation is assigned a unique name in the database. Representation of a relation, the way by which we can represent the relation. A relation or a table in which a row keeps the record of entity instances and each column holds the value of an attribute for the complete entity set. As you can see in the diagram, in this given table, each row is called a tuple and each column is called attribute and the whole table is called relation. A software used to manage the relational database is called Relational Database Management System, which is known as RDBMS. Representation of a relation by a given example. If you consider this example, it keeps a record of 6 students in 6 rows, which are also called tuples. This relation has 11 attributes. As you can see that there are 11 columns in the table, roll number, first name, middle name, and so on up to pin code. So these are the attributes of the entity student. Relational schema. A relational schema describes the relational table structure as it includes the relational name and name of attributes. Example of relational schema is of two relations like faculty and course can be written as faculty can be represented as faculty ID, first name, middle name, last name, designation, date of joining, gender, salary. And course may consist the attributes like course ID, course name, and course credit. The degree of a relation is the number of attribute in a relational schema. So the degree of schema faculty is 8 and the degree of relational schema course is 3 because course consists 3 columns and faculty consists 8 columns, that is 8 attributes. That's why the degree of the relational schema faculty is 8 and the degree of relational schema course is 3. Now, relational instance. The snapshot of data stored in a relation at any instance of time is called a relational instance. An instance of the relation student at a particular instance has 6 entity instances with 11 attributes. This is the instance of the relational schema. Now, database instance and database schema. The collection of data stored in the database at any instant of time is called a database instance. The overall design or structure of the database is called database schema. When the data is initially populated in the database, it is called the initial state. Any kind of modification changes the state of the relation in the database can be possible. The state of the relation in a database can change frequently, but the schema of the relations in the database is not supposed to change frequently. Database instance and database schema. If you consider this example as shown in the diagram have faculty, course, student, and department as the relations. So a relational database shown in the figure has 4 relations: student, faculty, course, and department, and each relation is represented as the form of table, and each column represents the attribute of the relation. Relational model. After designing the conceptual model of the database using the ER diagram, we need to convert the conceptual model into relational model. So let's understand what is relational model. Relational model represent how data is stored in the relational database. A relational database stores data in the form of relations, that is tables, as I told earlier. In the relational model, entity types and their corresponding relationship are represented by a collection of interrelated tables because of foreign key attachment. Each table is a group of columns and rows where a column represents an attribute and entity type and rows represent its instance. Tabular representation of regular, that is strong entity type. As I told in previous video, we have two types of entities, strong entity and weak entity. For each regular, that is strong entity type E in the ER schema, create a relation R that include all the simple attributes of E. The rules are, there are three rules. First rule, a entity type with only simple attribute will be converted into single relation, that is table. Attribute of the strong entity type will become the field columns of the relation. The key attribute of the entity type will become the primary key of the table. Let's understand this by the example. Consider this example. In the course, we have a course entity and attribute of the course are course ID, course name, and course credit, where course ID is marked as the underline. So course ID will become the primary key because course ID will be unique for each course. So three simple attributes, course ID, course name, and course credit, and key attribute are the key attribute is the course ID. The course entity convert into tables relation as name of the table course name of the relation attributes are considered here like course ID, course name, and course credit. And primary key of the relation is the course ID because it is the unique key. Tabular representation of weak entity type. For each weak entity type W, the owner entity type E in the AR schema create a relational R that include all the simple attribute of W and the key attribute of the owner entity type E. The rules are, there are three rules also. All the attribute of the weak entity form the column of the table. As in the strong entity case, key attribute of the weak entity type cannot form the primary key of the table. The key attribute of the owner entity type is added as foreign key column in the table. Fourth rule is that this foreign key column along with the weak entity key attribute column forms the primary key, that is composite key. As I discussed in the previous video, the concept of composite key in the case of weak entity. Two keys come group together in order to make the make a unique key. Tabular representation of weak entity type. Here you can see that entity B is a weak entity because it is shown in double rectangle, and B1 is the partial key because it is shown as the dotted line. Entity A is the strong entity and A1 is the primary key because it is represented as the single underline. So the weak entity B convert into relation will be the name of the table relation will be B, columns name of the relation will be B1, B2 and A1 because key attribute of A. A1 is the key attribute of A. So primary key of the relation will be partial key attribute of B plus key attribute of A. That is A1 and B1 will become the primary key of the relation. This is called composite key. Tabular representation of multi-valued attribute. For each multi-valued attribute A of entity type E, create a new relation R. R will have A and key attribute of E. The rules are, the relation R will include n column corresponding to multi-valued attribute. Remember this point. The primary key attribute K of entity type E add as a foreign key in the relation R. The primary key R is the combination of A and K. You can see by this example, phone number attribute of the student entity type are multi-valued because a student can have multiple phone numbers, which means student can have multiple phone numbers. The table name is the student phone number. The columns are phone number and primary key of the student entity roll number. So primary key is the roll number and phone number combined. So in the case of multi-valued attribute, we can combine the composite primary key along with the two attribute. So multi-valued attribute of the student entity will be roll number and phone number. Composite attribute. For a composite attribute A of entity type, we create sub attribute from the composite attribute and define a column for each sub attribute in the relation. For example, in student entity type, if you remember the table, or if you don't remember the table, you can see in the diagram where student entity type address is a composite attribute having house number, street number, city, state, pin code as sub attributes. So columns for address composite attribute are house number, street number, city, and state, along with pin code. So this is the way by which we can represent composite attributes. Now, there are some important questions which can be asked during your examination. So what is the process of converting an ER diagram, ER model to relational schema? How are the relationships represented in relational database derived from ER model? What role do primary and foreign key plays when transforming an ER model into relational table? This question is very important. How does the cardinality ratio between entities influence the structure of relational table? What challenges arise when mapping weak entities and their identifying relationship to relational table? So you can practice these type of questions for your examination. For further studies, you can refer these two books, Korth and Navate, which are these books are very important for the subject of database management system. And thank you for watching this video. I hope you got a clear understanding of the introduction of DBMS. Thank you.